Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Metals and Non-Metals. Metals have lots of uses in our day-to-day life, or we cannot even think of a life without metals. So large amount of metals are required for us. So from where are we getting these metals? Metals are mainly taken out from the earth crust. So they are found in the rocks. So usually we find rocks. The rocks may contain metals in it. So suppose this is the metal content in a rock, then it is called a mineral. Okay, so if metals are found in a particular rock, we can call it a mineral. There is another mineral with lots of metals in it. Okay, so here in the first one you see very less metal content. In the second one, large amount of metal is present in that element or a compound. It need not be rock, it can be the earth crust, any compounds also. So if there is large amount, we can extract the metal very profitably from this, because if you do all the work to extract metals, we will get very little, it's not that profitable. But if you do this, we will get a lot of metals profitably, and such minerals are called a ore. Ore of a metal. That means minerals from which metals can be extracted profitably are called ores. So you understood what is a mineral, what is ore. Mineral means a compound or an element which is present in the earth crust which has metal in it. But if it has large amount of metal so that we can extract them profitably out, then the same mineral is called a what? Ore. Okay, but sometimes usually earth crust we get, some minerals are obtained from the sea also. So we have various sources. Now when we are taking this ore, we got some ore, from that we have to get the purified form of metal. So the way of obtaining these metals from the ore, that is completely called as metallurgy. It's a branch of chemistry called metallurgy. So now we are going to learn about metallurgy. So there are different elements and we learned their reactivity series. Some are very reactive, some are moderately reactive, some are least reactive. So depending on their reactivity, the elements may be found in the free state or combined state in the earth. That means naturally they are either found in the free state. Free state means about elemental state. For example, gold, platinum. These elements are unreactive. They don't react at all, or they are at the bottom of the reactivity series. So they don't react with anyone. So we find them as such gold or a platinum only. It is not combined with anything else. But compound form means what? They are found as compounds. Means they may be reacting with the other elements. For example, mostly oxygen. So we will get the metal oxides from the earth. Or sometimes we get the sulfide if it is combining with the sulfur. If it is combining with the carbon, we get carbonates. So in different forms we get. Suppose if I get oxide or sulfide or carbonate, I have to make it into the pure metal, right? So there are different steps involved. These steps are common for all types of metals, whether it is in the free state or a combined state. There are a few steps to be followed, but their mode will be different. So first let us see the sequence in which we are doing the extraction of metals, then we will learn about each step in detail. So the first one is powder ore. Suppose if I am getting in the form of a rock or a huge chunk, then I have to first crush it into powder for easy procedures. So that's the first step, powdering the ore. Then followed by that we do a process called a concentration of ore, or it is otherwise called enrichment of ore or dressing of ore. What is meant by enriching the ore? Means the ore is a mineral which contains metals. That means it may have other impurities also in it. It's not that it's purely made up of metal. It has lots of impurities in it. So we have to remove all impurities and get only the metal. So that is called the enrichment of ore. So there we remove the impurities. The impurities are called gangue. Okay. So we learned three words. What are minerals, what are ores, and what are gangue. Gangue means what? The impurities present in the ore. So during enrichment process, the crushed powdered ore, from that we remove all the impurities and we get the metal in the form of either free state or the combined state. So usually if it is in the form of a sulfide, we do a process called a roasting. means heating in presence of plenty of oxygen. Whereas sometimes it is in the form of carbonates. The ore is in the form of carbonate. Then we heat in the absence of oxygen, that is called a calcination. So C for C you can remember. Carbonate means calcination. Sulfide means roasting, or it can be found in the form of metal oxide also. So even if it is in the form of sulfide ore or a carbonate ore, we are doing this roasting or calcination in order to make them into metal oxide, because refining or getting the metal from metal oxide is easy for us. So if I am getting metal as such, I am very happy. I can just purify it. Second, I am getting as metal oxide. Okay, again I am happy because I just have to remove oxygen. What is called a removal of oxygen? Reduction, right? So I am reducing so that I will get the metal. Now I am getting sulfide or carbonate ore. Not that happy, because if it is sulfide I will do roasting. If it is carbonate I will do calcination. So I am getting metal oxide. Now I can reduce it to metal. So whatever form we are getting, we will make it into metal oxide. Then it will be reduced to form the metal. Now what is the next stage? Reduction. Then followed by that we get metal. That metal should be refined. We have to get the pure form of the metal. So the last step is called the refining. The refining is done using electrolysis or electricity. So hope you understood these steps very well. First step, crushing of the ore into powder. Then we do enrichment of the ore or a concentration of the ore, where we remove all the impurities called a gangue. Third step is the conversion of the sulfide or carbonate ores into metal oxides by roasting and calcination. Then reduction of the metal oxide to metal. Then purification or refining of the metal into the pure form, that is by electrolytic refining. If you see the reactivity series, the top metals are reactive, we know, like potassium, sodium, calcium, magnesium, aluminium. All these are found in the combined state. So we will be using electrolysis to get the metal from it. Now coming to the medium reactivity series, zinc, iron, lead, copper and all, they are coming in the medium reactivity series. Now copper, mercury, silver, these three can be, they are low reactive, so they can be found in the free state or in the combined state also. Then gold and platinum, they are found only in free state. So if it is gold and platinum, we don't have to know about the procedure, just powder the ore, that is we have to remove the gangue and then refine or get the pure metal from that. No other procedure is involved. So now we will see the low reactive metals like copper, mercury, etc. So mercury is found in the form of its ore called a mercuric sulfide. Mercuric sulfide is called a cinnabar. Mercuric sulfide, it is the ore of mercury called a cinnabar. So since it is a sulfide ore, what are we supposed to do? Heating in the presence of oxygen, right? Heat. We have to heat it in the presence of oxygen. That is called a roasting, because sulfide ores are roasted. So what will we get? Mercury oxide and sulfur dioxide we will get. So here what are we getting? The mercuric oxide. So mercuric oxide, when you are heating, you will get mercury and oxygen will go out. Okay, so this is called a thermal decomposition. We are just heating to decompose it. You know, decomposition reaction means what? Reactant one, products are many. So this is called a thermal decomposition. It can also undergo self-reduction also. This oxide is reduced. Usually we use reducing agent for some metals, but here no reducing agent is required. It's just by heating we can make it into mercury. So we got the metal mercury. Now another metal with the same low reactivity series but found in the combined state is copper. Another element of the low reactivity series is the copper, which is occurring in the form of copper sulfide. Copper sulfide is the ore of copper called a copper glans. Okay, so copper sulfide also, first we have to heat in the presence of oxygen, then we call it as roasting. What will we get? The reaction will give copper oxide plus sulfur dioxide. Now this copper oxide we need to get in the form of copper. So copper oxide Usually we have to use some reducing agent, but here it is actually kind of self-reduction or auto-reduction happening. So the formed Cu2O will combine with the rest of the copper sulfide to form copper and sulfur dioxide. Okay, so this is how we are getting the metals copper and mercury. So mercury and copper are in the low reactivity series. So they are found in the free state or combined state. If it is in the combined state, both we are taking the example of a sulfide ores. The sulfide of ore of mercury is called a cinnabar and a copper is called a copper sulfide. Mercury sulfide is first roasted to get mercuric oxide. Mercuric oxide under thermal decomposition becomes mercury and oxygen. Whereas copper sulfide on roasting is copper oxide. Copper oxide will undergo self-reduction or auto-reduction to become copper and sulfur dioxide. Now we will discuss the metals in the middle of the reactivity series like iron, zinc, lead, etc. Copper also. So these are mostly found in the combined state, either in the form of sulfide or in the form of carbonate. We learned if it is in the form of sulfide, we heat them in the presence of excess air. The process is called a roasting, so that we will get the metal oxide. If it is in the form of carbonate, we heat it in the absence or limited air, then we get the metal oxide again. Why are we converting it into metal oxide? Because getting metal from metal oxide is easier than getting from its compounds like sulfide or carbonate. So initially we will convert it into oxide. Now this oxide we need to reduce. Here we need reducing agents. Okay, so there are two types of reducing agents used. Either we can use reduction reaction using carbon, coke, which is a form of carbon, that is called a smelting. Or we can use displacement reaction also. Some highly reactive metals like aluminium are used for displacement of the low reactive metals from its oxide. Both these processes can be used according to the need. But before that, remember, the initial steps remain the same. First we have to powder the ore, then enrichment or a concentration of ore in order to remove the gangue. After that only we go for roasting or a calcination. Let us take an example of a zinc. Zinc is present in both the forms, sulfide form or a carbonate form. So if it is present in the sulfide form, zinc sulfide, then we call it as zinc blend. Then if it is sulfide form, zinc blend, what do we do? Roasting, means in the presence of excess of air. So we will, if you heat, what will you get? Zinc oxide plus sulfur dioxide. So here, the same way we will. Now we got zinc oxide. Now if it is in the form of zinc carbonate, ZnCO3, which is zinc carbonate. If it is in the form of carbonate, what do we do? Calcination, that is limited supply of oxygen, so we don't have to write oxygen, we are just heating. What will we get? Zinc oxide plus carbon dioxide. Okay, so this is what we are getting. Now this is called, zinc carbonate is called a calamine. That is the ore. So now we learned 4 ores. NCERT is not mentioned. If you can remember, well and good. Okay, now both these cases, what did we get? Zinc oxide we got. We are using carbon to reduce it. Carbon is or coke is used as a reducing agent. So zinc oxide is now heated in the presence of coke or carbon. What we get? Zinc plus carbon monoxide. So now we got our metal in the pure form, that is the zinc. Now we have to do refining of this metal to get it the completely pure metal. So reactivity, middle of the reactivity series, what are the elements? We have zinc, iron, lead, etc. Of this we are taking the example of zinc, where first if it is in the form of sulfide, roasting to become oxide, carbonate, roasting, calcination to make it oxide. If you get oxide, we are using a reducing agent like carbon to make it into the metal. Now we will see how can metal oxide be converted into metal using displacement reaction. For that we have to take some metal which is more reactive than this particular metal to be isolated or reduced. We are taking an example of manganese oxide, which is heated in the presence of aluminium. What will we get? Manganese and aluminium oxide. When this reaction happens, a large amount of heat will be released. So here, instead of using a reducing agent, we are using a highly reactive metal to displace the metal from its oxide. So we know that here manganese dioxide is getting reduced to manganese, whereas aluminium is getting oxidized to aluminium oxide. But here I wrote heat. That means this kind of reactions are highly exothermic. So we are making use of such reaction in a different part. For example, another metal oxide is iron, that is Fe2O3. Iron oxide, that is also using displacement reaction using aluminium. What will we get? Iron and aluminium oxide. Here also we get large amount of heat. So since the heat is so huge that it will make the metal in the form of a liquid, okay, molten state. It's almost a melted state we are getting the metal. So this can be used because iron, we are making lot of equipments using iron, huge machine parts or railway tracks and all. But if there is a crack, how can we stick them together? Can we use any glue? No. We need a liquid metal itself. So we will be using this reaction to make molten iron, which can be used for sealing the cracks or any damaged parts, so that it will stick on cooling down, it will solidify and stick there. Okay, so this reaction is very important. This is called a thermit reaction. So it is a displacement reaction using aluminium, where iron oxide it is displaced using aluminium. So we get iron and aluminium oxide, but this is a highly exothermic reaction. So it is used for, as a result, the metal is available in the molten state. So we use it for sealing the cracked railway parts or machine parts. Now we will see metals high at the reactivity series like sodium, potassium, calcium, magnesium, aluminium, etc. So here mostly they are highly reactive. So of course they are not going to be found on the free state. They are found as their oxides. So if they are found in oxides, we can easily reduce them, right? But remember, first powdered ore, then enrichment of ore to remove gangue, then only we are coming to oxides. But here, usually we are using carbon to reduce these oxides. But here, for high reactivity metals, carbon will not work as a reducing agent. The reason is these carbon cannot reduce them because these are all highly reactive and they have more affinity for oxygen than carbon. So we have to switch to some other method here, that is called the electrolytic reduction, because reduction using electricity. So if we are getting the chloride of that metal, then we are taking the molten solution of that chloride, means the liquid form. So the molten chloride solution, for example, if I am taking sodium chloride solution and I have anode and a cathode, it is connected with electricity. So once electricity starts passing, it will ionize. So chlorine ions are negatively charged, so naturally they will be coming or attracted to the positively charged anode. So on reaching the anode, the chlorine will lose its electron. As a result, it will become chlorine, right? And these electrons will pass through this wire and reach the cathode where sodium is there. Then sodium will receive this electron coming from chlorine and it will get reduced to sodium. So here the reduction is using electricity. So this reduction is called an electrolytic reduction. Aluminium is also obtained by the reduction of aluminium oxide. We are moving on to the last stage of metallurgy. We started with the powdering of ore, enrichment of ore to remove gangue, then we did a roasting, calcination, whichever was required, then reduction to metal, metal oxide to metal, and now last stage is purification. Initially we removed the gangue, but ultimate purification was not done there. Now we removed from the compound stage them into the elemental stage or the metal, pure metal stage. Now again impurities may be there, that can be removed using a method called electrolytic refining. Refining means purification using electricity. We can use zinc, copper, tin, nickel, aluminium, gold, all these metals can be purified using this method. So here also we are using anode and a cathode. Here what is taken as anode, what is taken as cathode is very important. Whatever metal we have to purify, that means the strip of metal will be there which we need to remove the impurities, that will be taken as the anode. But we have already prepared some pure metal that will be with us, that thin strip will be taken as the cathode. Now they are connected, but we need an electrolyte. Here the electrolyte is the salt solution of that metal to be purified. For example, in this we can see copper. If we are refining copper, we can take the acidified salt solution of copper, maybe copper sulfate solution acidified. So now when we pass electricity through this, what happens is from this impure metal that is present at the anode, the copper metal will come down to the solution. Okay, so when more and more copper comes into the solution, equal amount of the pure metal from the solution will go here. Only copper will go and attach to the thin strip. Over a period of time, this will become thicker. Okay, so metal will be dissolving, coming out of this into the solution. From the solution, equal amount will be attached to the cathode strip. So when it is coming, impurities will also come. Of this, soluble impurities will dissolve in the solution. We can discard it later. And insoluble impurities will come and settle near the anode. That is called a anode mud. So if you can remember the anode mud, you know where the impure metal is kept. Anode. I usually remember like that. Okay, so anode mud is the insoluble impurities formed from the impure metal strip. So impure metal strip is taken as the anode because we know about anode mud. Okay, so this is the final process, electrolytic refining. So these stages are very important. We learned the refining or extraction of highly reactive, moderately reactive and low reactive metals. Hope you are enjoying my lessons. I would like to know about your experience through the comment box, and also please like, share and subscribe to my channel Biology My Passion. Thank you for watching.